Hello everyone, hopefully you're doing well. In this video, we're going to have some very good fun exploring data with tables and graph in chapter 2. In this chapter, there are so much we're gonna cover, and that will be very helpful to the end because this chapter would really focus on important characteristic of data, like we're going to take a look on center, that a representative value that shows us where the middle of the data set is located. We're going to talk about variation, a measure of the amount that the data values vary, and distributions like the shape. Whether you have uniform, skewed left, skewed right, is it symmetric? Is how the data spread, okay, over the range of values. The outliers, we talked briefly in chapter 1 about outliers. In this case, we're going to use more sample values to see how they lie far away from the vast majority of other sampled values. And of course, we're going to talk about time, any change in the characteristic of the data over time. But that's a whole chapter. However, in chapter 1, in section 2.1, we would take a look on frequency distribution for organizing and summarizing data. So the idea is to develop an ability to summarize data in the format of a frequency distribution and relative frequency distribution, or we can call it percentages. For a frequency distribution, we would identify values of class width like lower class limit, upper class limit, etc. Class midpoint. We're going to talk about class boundaries. We're going to talk about cumulative frequency, etc. So, hanging out with me, we are ready to start, but let's see some key concepts. So, when working with large data sets, a frequency distribution or a frequency table is often helpful in organizing and summarizing data. So a frequency distribution helps us to understand the nature of the distribution of a data of a data set. Or also, like construction of a frequency distribution is often the first step of constructing a histogram, which is a graph used to help visualize the distribution of data. So what we need to see here, anytime you have a data set, you're going to have a frequency distribution. Like if you have a data set with a lot of numbers, now we're going to see how often each data is repeated. What is the frequency? Now, what is the tally? So you need to count each data, how many times each data is repeat, and then you're going to display it in a tables with the interval, the class or the X, what the data you are interested in, and the number of times it's repeat, the number of times each data is repeat, we call it frequency. And at the end, we need to add them up all together to find this total data in the data set. We're gonna go over many examples, and that will help us to understand better. So a frequency distribution or a frequency table show how data are partitioned among several categories or classes by listed the categories along with a number of frequency distributions. Now, let's suppose we conduct a study in a small town called Cranston, for example. We need to see TV set per household. So if we want to see the number of TV set per household and, sample, then suppose we have a sample of 15, for example, at households, 15 household. So we went and see some household has, with the first household we find zero TV. The second household we find one. The third household we find three TV. fourth household, zero TV. The fifth one, we find one TV. We find two TV in the next one, zero TV in the previous one, one TV, two TV, three TV. Um, at least we find one with four TV, and we again find three TV. We find two, one, zero. Let's see if we already have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, you see, this sample size is like the number of household, the number TV per household. So the first household we check, we ask questions, how many TV sets you have in that household. They tell us it was zero TV. The second household said we have only one TV set. The third household said we have three TV. The fourth household we said zero TV. Now, if we want to construct a frequency distribution, the first thing to do, we can put it here as the number of TV. I can call it TV sets. All right. Some has zero TV, some has one TV, some has two TVs, some has three TVs, and some has four TVs. So this is our we call this a frequency distribution. So if we take this one as a frequency distribution. Now, our goal is to find how many TV set how many household has zero TVs. So what we need to do is count. One, two, three, four of them says they have zero TV. How many says they have one TV? One, two, three, four says they have one TV. How many says they have two TVs? One, two, and three. Three says they have two TVs. How many says they have three TVs? One, two, and three. Three says they have three TVs. How many says they have four TVs? Only one of them. So when you do that, make sure you add them all together. You need to add them up all together because you need that total if you want to compute the relative frequency. Now, you need to add 4 plus 4, that's 8 plus 3, 11 plus 3, 14 plus 1, 15. So this is the 15 household. So that's what we call you know, a frequency distribution table. The column where you see the TV set, now you only have like, it's a single grouping because you only have one data, all right? But very often, it shows how data partition among several categories or classes by listing the categories along with the number of data values in each of them. But usually it's class. So sometimes we can just list them in a single grouping method, but not all the time it's going to be single grouping. Sometimes you need to construct some class interval. We would have a chance to see it over them. So that's what we said here. When you construct a frequency distribution tables, you need to identify the lower class limit. So if we start, let's suppose, for example, in a data set, we can consider the class, like let's suppose class intervals, or you can call them class interval or intervals. Let's suppose you want to organize, you need to arrange students age 15 to 70, so 15 to 50, 15 years old to 50 years old. So, you have students in a community college age from 15 to 50 because you cannot do single grouping with this one. You're gonna group all students 15, all students 16, all students 17. We cannot do it like we did for the TV because the TV has only five different ones, 0, 1, 2, 3, and 4. But if you try to do 15 to 55, you need to do like 36. So you don't want to do this. In this case, it's better you construct class interval. So you can take all students from 15, let's say you said students from 15 to 25. So if you 15 to 24, so we know next would be 25. 25 plus 10 make it 35. So we're gonna make this one 34. 35 plus 10, 45. So we're gonna make this one 44. 45 plus 10 would be 55. So we make this one 54. So what we don't need the last class because we know all our students would be, the age would be from 15 to 55. The lowest age would be in the first class, 15 to 24. And the older student, 50 years old, would be in the last class, 45 to 54. So we make sure you count all students age 15 to 24, you as the frequency and put it in the first class. In the second class, you count all students from 25 to 34, then you put it in the second class. In the third class interval, you count all student age from 35 years old to 44 years old, and the last class, 45 to 54. I hope you understand it, but let's suppose what you see here is that these numbers, the lowest one, we call these numbers in the class interval the lower class limit. Those are lower class limit. And those are the the lower class limits, the smallest numbers that can be long to each of the different classes. The upper class limits, the largest numbers, so these are the upper class limits. Upper class limits. All right. Now, we see also class boundaries would be something different. Class boundaries, if you try to construct a histogram, it's extremely important to remember after you do this, that would be the frequency here. Remember, you're gonna count all the numbers, but in order to display these data in a graph, we're talking about it, so those are quantitative data, and quantitative data can be displayed using a histogram. In order to do that, you can construct what we call the class boundaries. But this is how the class boundaries work. So we're gonna class boundaries. For the class boundaries, we said take zero point 0.5 from the lower class limit. If you take off 0.5 from the lower class limit, what should you have left? Yes, 14.5. Now you need to add it to the upper class limit. That make it 24.5. And you do it for all the other classes. You take off zero point 0.5 from the lower class limit. You add it to the upper class limit. You take zero point 0.5 from the lower class limit. You add it to the upper class limit. You take 0.5 to the lower class limit, you add it to the upper class limit. So we call this class boundaries. The reason why we do that is because if you look at the first graph, if you want to construct a bar, remember when you construct a bar, what's going to happen with those bars? Suppose you put 15 here, you put 24. Now, next class would be 25 and 34. So what happened, you see, when you put those bars, there would be a gap between the bars because between 24 and 25, there would be a gap. However, if you remove zero point 0.5 from one of them and you add it to the next one, it would be different. Let me show you something. So if we have 14.5 to 24.5, now next class will be 24.5 to 34.5. Now, etc. So you see, when you use this bar and here, but the other bar gonna start exactly the same place, so they would attach to one another. In a separate video, I will do some examples using Excel or StatCrunch, so you can see how to do the same thing using Excel or using technology. But now I'm going to do it manually for you in a multiple examples. Now, class midpoints, again, if you want to construct class midpoint, you can take exactly the same examples you see here that I show you. If we go down here with class midpoint, I'm going to put it here. All right. So if I want to add class midpoints to this graph, midpoint means we need midpoint. You take the two different limits. You have the lower limit plus the lower limit plus the upper limit. You divide by 2. So that's make it 15. I'm going to grab a calculator because I take a random examples. So I said 15 plus 24 equal 39 divided by 2. That's 19.5. And you're going to do exactly the same thing for the second class interval. You take the 25 plus 34 divided by 2. So you take 25 plus 34 divided by 2. It's going to give you 29.5. If you do 54, 35 plus 44 divided by 2, it should give you 39.5. If you do the 45 plus 54 divided by 2, it's going to give you 49.5. So I'm hoping you can use these examples to see, you know, how we can find the frequency distribution, the class boundaries, the midpoints, and also we can do class widths. Okay, class widths, as you can see, all the classes I have here has the same width. If you do 24 minus 15 is 20, is 9. 34 minus 34 minus 25 is 9. 44 minus 35 is 9. 54 minus 45 is 9. So the width must be the same. But how did we compute the width? The width, you need how we find the width? We find the width by subtracting the two lower limits. So that means the width here can be 25 minus 15. You see that's 10. Or if you want, you can do 34 minus 24. It's also 10. And you would see any two, any two upper limits you take, any two consecutive upper limits or any two consecutive lower limits would be exactly 10. So sometimes it's given, because it's not something you do randomly. You need to really think about it because you need to set it up in a way that there is not a big gap in the last class. That means the largest number in the data set would fit into the last class interval, and the lowest number in the data set would fit in the lower class. So we have so much like this to cover. As we said, how to proceed to construct you see because we said like here for the midpoint with the width we said is the difference between two consecutive lower class limits or two consecutive upper class limit in a frequency distribution. So that's what we do. Now we see in the next slide we're going to provide you with the procedure to construct a frequency distribution. The first thing to do to construct a frequency distribution, you need to summarize, okay? To construct frequency distribution to summarize large data sets, all right? You need see, you need to verify, I mean, so you can see the distribution of the data or identify any outliers or have a basis for constructing graphs like histogram, Of course, as I said, we're going to use technology also to generate all of this. So the first step is to select the number of classes. So in the previous examples here, you see I have four classes. You see, I have 1, 2, 3, and 4. 4 classes. Now, usually it tells you the number of classes, but you don't want to have less than 5 or more than 20, right? The number of classes might be affected by the convenience of using round numbers, right? That's very important to verify. Of course, if you had a chance to take a class like quantitative reasoning, you understand Sturge guidelines. So the ID number of classes for a frequency distribution can be approximately 1 plus log n over log 2. So where n is the number of data. So for us, if we want to find this one very quick, we can do 1 plus log n over log 2. So it's going to give you the number of class. But of course, n is the number. Remember, n is the number of the data in the data set. So n is the number of the data in the data set. So, all right. But calculate the class width. Remember, the class width sometimes is given, right? Or how to find the class width? Class width is the maximum minus the minimum over the number of class. Number of class is given, but remember the range of the data is the maximum minus the minimum. So we call it range. So when we find the class width, we said class width we said is the range over the number of class, right? So number of class in the exercise usually is given. You don't need to pay to you know fight for this one. It's okay. So round this result to get a convenient number. It's usually rounded up because you want to make sure everything is so to continue with the procedure for constructing a frequency distribution, the third step is to choose the value for the first lower class limit by using either the minimum value of or a convenient value below the minimum. So remember, they would tell you, okay, start with that particular number as the lower class limit. But using the first class limit and class width, list the other lower class limits. Remember, if the first lower class limit, for example, is 15 and you had the width equal 10, you know the next one would be 20. Okay, I'm gonna change it different way. Let's suppose the lower class limit, if the lower class limit is 5, okay, uh, I'm gonna put 0. If the lower class limit is 0 with a width 5, so you know the next one would be 5, so this one would be 4, 10, so this one would be 9, 15, so this one would be 14, 20, so this one would be 19, 25, so this one would be 24, and 29. So that would be 1, 2, 3, 4, 5, 6. So number of classes in a random data set that I just take here would be 6 classes. So after you list the lower class limits in a vertical column and then determine and enter the upper class limit, take each individual value and put a tally mark in the appropriate classes that we call frequency. Add the tally marks to find the total frequency for each class. Remember that it's very important to do. So what you need to remember when you construct a frequency distribution, be sure the class do not overlap. Each of the original values must belong to exactly one class. You cannot have a number in the data set that correspond to two different classes. Include all classes, even those with a frequency of 0. Try to use the same width for all classes, although it is sometimes impossible to avoid open-ended intervals, such as like 65 and over, for example, or 45 plus, if we talk about people's age. All right. So the other and very important information that you can find in this one is the relative frequency distributions. So what I'm gonna do, let's put this one a little bit lower than that. Um, just to show you something. Okay, let's go back and copy this, our little examples here. I'm going to copy it and go back on that relative frequency. I put it here. Now you understand what I was doing. You know, suppose, oh, you know what? I'm not gonna do it with this example, sorry. Not these examples. Let's go with the first one. I'm gonna take the first examples I use. That was this one, the TV sets. Remember for the TV sets, we have, that's a single grouping. So single grouping means, okay, this is a single grouping. Okay, now I have the frequency. I may want to also include the relative frequency. Relative frequency is the same thing like expressing whole number in terms of percentages. Let's say, for examples, in a class of 28 students, okay, 17 of those students identify themselves as females. 17 identify themselves as females. What is the percentage of female in this class? How would you find the percentage of female in this class? Yes, to find the percentage of female in this class, you would take 17 divided by 28. So you would say 17 divided by 28. That gives you 60.7% of students in that class is identify themselves as female. So that's what the relative frequency does. So if you want to convert, four among 15 households visited, four households identify that has no TV at all. So if I want to express the four household with no TV in terms of percentage, what I would do, what should I do? Yes, I need to divide 4 by 15. And I would do the same for the second one. I would do the same for the third one. I would do the same for the fourth one. And I would do the same for the last one. So that's what we call relative frequency. So relative frequency distribution or percentage distributions, because that's very important to see. We're gonna continue to review all of this. We said the variation of the basic frequency distribution is a relative frequency or percentage frequency distribution in which each class frequency is replaced by relative frequency or proportion or percentage, right? So each class, so relative frequency for a class is the frequency for that class over the total sum of all frequencies. Or you can multiply whatever you find by 100 because anything you find would be in decimal 0 point something. If you multiply it with 100, then you would obtain the percentage. Very important to verify all of this. Relative frequency distribution or percentage frequency distributions. As I said, each class frequency is replaced by a relative frequency. All right. So the sum of the percentages, okay, in a relative frequency distribution must be very close to 100%. So when you add up all your percentage together, make sure it's equal to 100%. Cumulative frequency, it's something different. If I take the same examples I have here, when I find the probability, the frequency, because remember, if you do 4 divided by 15, all right, it gives you 0.267. 0.267. Now, if you do 3 divided by 15, it gives you 0.2 and 0.2. If you do 1 divided by 15, it would be 0.06 7, right? So this is what we call the frequency, the relative frequency distribution. But one more column we can add in this one that I would copy and bring to the last slides here as an example, the cumulative frequency distribution. So cumulative frequency distribution. What we call cumulative frequency distribution, that's it's a distribution in which the frequency for each class is the sum of the frequencies for that class and all previous classes. Look, if I'm here, if I'm on the first one, it's 4 plus whatever I had before that. What I have, I didn't have anything before that, so that's remain 4 for the first one. For the second one, I take whatever I have here, which is 4, 4 plus 4 give you 8. Now on the third one, remember, take the frequency of the current class, which is 3, 3 plus the previous class frequencies, which is 4 plus 4 plus 3, that make it 11. Now let's do it for this one also. 3 plus 11, that's 14. 14, 1 plus 14 is 15. So we call that cumulative frequency. But one thing is certain, we're gonna have a chance to do real exercises. As I said, my goal in this case is to do one or two examples very quick with you, and you know, with the goal that you would continue to do the same thing with the homework and everything. So let's see what the next examples would be. Eventually, we would review. What I'm going to do is copy paste. So you see, I would remove the exercise B because we're going to focus only on exercise A. What they ask you to do in these examples, identify the class width. What is the class width based on what you already learned? Class width. Class width, you need to subtract two consecutive lower limit or two consecutive upper limit. Okay, so either two consecutive lower limit or two consecutive upper limit, you can do it. So class width in this case would be what? Yes. So we're gonna have 30 minus 20 is 10. So we know the class width would be 10. Okay, so because we covered that already, hoping you see what it is. Now, our next questions, because now we can say done, we identified the class width. Next is the midpoint. So we said for the midpoint, I'm gonna just add this colon. I'm gonna add this colon right there. Everything I need, I'm gonna just add it to make it faster, okay? Remember for the midpoint, what I said, you add for each class, add the lower limit to the upper limit and divide by 2. So every time you do that, of course, you're gonna find the midpoint. So we go, it's like you do 20 plus 29 over 2. If you do 20 plus 20 plus 29 divided by 2, that gives you 24.5. So this would be 24.5. And I'm not going to show you the operations all the time. So I'm going to do only the first two. So you see what we do. Then you can continue doing it. So if you do 30 plus 39 divided by 2, that make it 34.5. 40 plus 49 divided by 2, that would be 44.5. 50 plus 59.5 divided by 2, that will give you 54.5. 60 plus 69.5 divided 60 plus 69 divided by 2 might give you 64.5. And the last one, 70 plus 79 divided by 2, that would be 74.5. So I did it and I know what the answer would be. I'm hoping now class width is okay because you focus on the class intervals. Take the two for each class, take the lower class limit, add it to the upper class limit, and divide by 2 for each of them. That's how you would find the midpoint. Now, that's a line that would fall exactly in the middle of each bar on your bar graph or your histogram, etc. So we would have a chance to go over it. Now, next is the class boundaries. They ask us to construct the class boundaries. So class boundaries. I put this in the table so you can continue to do it on your own. Okay. Voila. Now, let's see. I'm going to take a different color. Let's take red. Okay, class boundaries. If you remember the previous simple examples I took to explain class boundaries, for each class interval, remove zero point 0.5 from the lower class limit and add it to the upper class limit. That means if I have 20 now, I no longer have 20, I have 19.5. I need to add it to the upper class limit that make it 29.5. I do the same for the next one. Instead of having 30, because I remove 0.5, it would be no longer 30, but it would be 29.5, 39.5. I add it up there. For the third class interval, I no longer have 40, 49. I would have, because 40 I remove 4.5, it make it 39.5, 49.5. Now, 49.5, 59.5. 59.5, 69.5, 69.5, 79.5. So what you see in the class boundaries, the upper limit of the previous class become the lower limit of the current class, right? So every time the upper limit ends with something, the next class would start with the exact same value. You see, the first class, the upper limit is 29.5, so next class would start with 29.5. So because we want to connect each bar, because that's something you would learn in the future. Now we answer the question asked. The first question, so this was to identify the class with the class in the midpoint, class boundaries for the given frequency distribution. Also, all right, also, oh, they asked us to add more to it. Also, identify the number of individuals included in the summary. So remember, the second column will provided you with the frequency. Each class interval has a frequency, like 20 to 29 has only one, 30 to 39, you have 29, 40 to 49, you have 38, 50 to 59 has 16, 60 to 69 have 6, etc. Now, what's the sum? These questions means identify the number of individuals included in the summary. So if you add everything together, I mean 1 plus 29 give you 30, plus 38, plus 16, plus 6, plus 1. I believe that gives you 91. You can verify, but the total here is 91. Now, it's very important to use that total to construct the next column because they ask you to include the relative frequency. Relative frequency. So relative frequency, as I said in that tables, is when you convert every frequency to decimal. Like 28 students in the class, from 28 students, 17 identify themselves as females. So what we would do, we're going to take 17 divided by 28 to find the percentage of female. So here, only one identify themselves age from 20 to 29. So what we're gonna do, remember in this case, you're gonna have 1 divided by the total, which is 91. Answer. 29 divided by the total, you have 38 divided by the total, you have 16. No, I read too hard, too big. 16 divided by the total, 6 divided by the total, and 1 divided by the total, right? So we're gonna do it this way. Very important to use it that way. All right. So this is what's gonna happen. Now you just grab your calculator and perform these operations. So the first thing, we can do it one by one, because I'm gonna teach you how to do the same thing using your Excel or StatQuest. So 1 divided by 91 would be, if I take 4 digits, 0.0111, okay? 1, but because we have that, I take 3 digits. If you do 29 divided by 91 would give you 0.318687. We have 38 because you take each frequency, you divide by the totals, it gives you 0.4175. And now you have 16 divided by the total. It gives you 0.1758. And if you have only 6 divided by the total, remember 6 divided by 91, it gives you 0.0659. And the last one again will be the same because this was 0.011. So remember, we said that before, the sum of the percentages in a relative frequency distribution must be very close to 100%. Make sure when you add, probably the answer would be 100%. You convert each frequency to percentage or to relative frequency, right? Now, last one is the cumulative frequency that I told you about. So if you do cumulative frequency, and that's the last part, we continue with the table like this. Remember, our goal is to show you how to do it also on Excel. So cumulative frequency, we said that's the way we do it. Each class is the sum of the frequencies for that class and all the previous class. Now, if I want to add everything from the previous class, from the first one, 1 plus everything previously, there is nothing before 1, so it's 1. Here, when we have 29 plus everything that's come before 29, what's come before 29? Yes, 1. 29 plus 1 is 30. In the third class, we have 38. 38, you take 38, add it to everything that you find previously. So 38 plus 30 give you 68. Now we are with 16, right? 16 plus 68 give you 84. 84 plus 6 give you 90. 90 plus 1 plus 90 give you 91. So that's what we call cumulative frequency. So we said in the book where you can find these examples, I wanted to make sure that from the previous exercise, I do only exercise A, so I leave you enough time to work on number two and B, so you can practice on your own and do not hesitate to let me know if you have any questions about it, because there is a lot to cover in these sections. In a in next video, in next I think now I do these introductions, and it's very important to stop there because we have a few exercises that would require that I take longer to do. I would come back in a different video to do some exercises, and that would cover how you can construct a frequency distribution, because these examples here you already have the class interval and the frequency, but we will do it in a different video. Take care. I'll see you soon.